So we're solving inequalities. Now it's just like solving an equation, except instead of an equal sign, we've got this inequality here, which means when we're done solving, we also have to graph our solutions, because it's more than just x equals 2. It's going to be more than that, and so we're going to have to graph it to identify what else is there. So let's start with solving. We look at x. It says x plus the 2. I'm going to subtract both sides by 2. Now that seems pretty easy. So we get x is greater than 2. 4 minus 2 is 2. And so now we're looking at what numbers are greater than 2. Now I'll just quickly talk about graphing. After this, I'll just graph pretty quickly. So I've got 2 on the number line. Now some people like you to actually graph out more numbers. I'm not really all that particular about that. Okay, now it says that it's greater than 2, which means it doesn't actually equal 2. It's always bigger than 2. But we still have to signify that we start at 2. So I'm going to use an open circle because it says I'm starting there, but I'm not actually including the number 2. But we can't put a dot somewhere else because the number 2.1 is a solution, because 2.1 is bigger than 2. So to signify something just minutely beyond 2, I'm just going to have an open circle, and I'm going to say, you know what, bigger numbers go this way. Like the number 3 would be a solution, and the number 4 would be a solution. So this arrow that I draw is just saying all of these numbers that this arrow goes over are solutions, are numbers that I can plug in for x and get a true statement here. So my answer is x is greater than 2, but it's also this graph, and I need to see the graph every time. So let me go to our next problem. It says x minus 6, so I'm going to add 6 to both sides. Now the 6's cancel, and x is less than or equal to 13. So then I graph. I put a 13 on my number line. Now this time there's that line underneath, which means it also is 13. So it's 13. So I close it. It's called a closed circle. I fill it in to say I'm including the 13, but then x is smaller than it, so I have to go to the left for numbers that are smaller than the 13. Okay, we also need to be able to multiply and divide. So here I have 2 times x, so to get rid of it, I divide by 2 on both sides. And when I do that, I get x is less than 4. And then I draw a number line. I'm going to put my 4 down. It's just less than, so I have to do an open circle. And it says x is smaller. Numbers that are smaller than 4 are over here. That means my line, my arrow needs to go over here. And then I have the 4th one here where I'm dividing by 4, so to get rid of it, I multiply by 4. Okay, so then we get x is greater than 12. So I draw my number line, put a 12. It's just greater than, so I put an open circle. Numbers greater than 12 go to the right, so my arrow goes to the right. Now this all seems so simple, but there's a little bit of a glitch in this. Because when you're multiplying or dividing, if you have a negative number that you multiply or divide by, you have to switch a sign. For example, here I divide by -4. Now notice the number in pink is -4. I'm dividing by -4. And therefore, if I'm dividing by -4, when I rewrite it, I have to switch the sign. So now it's greater than or equal to a -4. And then I draw it just like I normally would. So x is greater than, it goes to the right, bigger numbers are on the right. So again, if you divide by a negative, and that's the big deal, is the number you're dividing by is negative, then you have to switch the sign. The same thing goes for multiplying. On the next one I have x divided by -3, and I have to multiply by -3 to get rid of it. And so because I multiplied by a -3 on both sides, I have to switch the sign. And then I can graph it. It's just an open circle, and x is smaller, so it goes to the left. Now this only happens for multiplying and dividing. If I'm adding or subtracting, I don't care if the number is positive or negative. It's just that when I'm multiplying or dividing by a negative, remember how if you have a positive times a negative, it becomes a negative? If you have a negative times a positive, it becomes a negative. Well, because of those rules, what's happening is it's switching which one's bigger and which one's smaller, which means this inequality that I have here is switching. And so I have to switch it then also when I'm solving.